Clark here at Killer Fun, back with another Daily Killer Sudoku solve video. This is puzzle number 1636 at dailykillersudoku.com. And like most of these videos that I make, was a challenge to conquer and an opportunity to improve. Let's look at the puzzle and see what we can learn before we start the solve. This is a difficulty 4 puzzle with an average solve time of 31 minutes. The board has no symmetry, so if you find an action in one part of the board, there will not be a similar possibility symmetrically across the board. There are also several odd-shaped and larger cages. This 6-cell 28 cage, a 7-cell 40 cage, 2 6-cell cages starting in box 5, a 25 cage and a 26 cage, this 5-cell 27 cage. Compared to these, this 6-cell 36 cage and 4-cell 27 cage are pretty boring. Because of these unique shapes, there are not many areas of the board that are conducive to Rule of 45 possibilities. There are only a couple available that we will use. So let's get started. If you would like to follow along or give it a try first, there is a link to this engaging puzzle in the description. Starting in box 6. With this 3-cell 7 cage, the only combination that works is 1, 2, 4. Moving to box 2, 2-cell 3 cage, the only combination is 1, 2. And in box 1, a 2-cell 4 cage, the only possible combination is a 1, 3. With the 1s here, this is the 3, and this is the 1. Now this 1 helps us with this 28 cage. This 6-cell 28 cage has 7 different combinations, 6 of which contain a 1, all of which we can remove, which leaves us with a 2, 3, 4, 5, 6, 8. Now I'm not going to enter those. I don't want to muddy up the board. But if we notice that the only numbers that are not in that combination are 1, 7, 9. And that helps us here. There's already a 1. So these 2 cells must be a 7, 9 pair. And looking forward, if we put the 9 here, this would need to be a 3. So this is actually the 7 of the pair. And this is the 9. So this is a 6. And this would be a 5. Now the remaining candidates in box 1 are 2, 4, 8, and the 5 cage cannot contain an 8. Let's put in its pair. With the 2 there would be a 3, with the 4 there would be a 1. All right, let's move to box 6. So here in box 6, there is a Rule of 45 opportunity. The combined sum of the highlighted cages is 40, and we know that all of the digits in a box sum to 45. So 45 minus 40 is 5, so this cell here is a 5. And jumping down to box 9, we can do the same thing. The combined sum of all the highlighted cages is 41, meaning this cell is a 4. And a 3-cell 21 cage with a 4 must also have an 8, 9, and we can do that for those cells that stick out into box 8. Let's move back to box 6 here. This 5 and the 2 and the 4 in this 3-cell 7 cage limit down the possible combinations for this 2-cell 11 cage. We can remove this because of the 5, we can move the 4, 7 because of the 4, and we can remove the 2 because of the 2s in the 7 cage, leaving a 3, 8. And the remaining cells in the 3-cell 22 cage are 6, 7, and 9. All right, so let's look at box number 7. So this 5 cage, 2-cell 5 cage, it only has 2 possible combinations to start with, and we can limit it down even further because of this 1-3 that's here. So of the 1, 4, 2, 3, this cannot be a 1 or a 3, so it could be a 2 or a 4. And the partner of those two in this cell would be 1, 3. And that's going to help us further on in the puzzle. This 1, 3 pair will. So that brings us to the first crux. This is a 1 in and 1 out rule of 45 opportunity down here in the, well, most of box 7. The combined sum of the highlighted cages is 45, and what that means is that this cell here and this cell here are equal. In addition, because we know that they're equal, all of the parts of the board that are visible by this cell, meaning everything in its cage, everything in its row, everything in its box, and everything in its column, everything that it sees is also seen by this cell because they're tied with this 1 in, 1 out rule of 45 combination. And vice versa. Everything in this cage, everything in this box, everything in this row, and everything in this column that this cell sees is seen by this cell. So let's use that to our advantage. So we'll start down here in row 9, column 4, and let's start with the limitations that this cell already has because of it is a 27, a 4-cell 27 cage. It cannot contain a 1 or a 2. In addition, because it's in this box here, it can also not contain an 8 or a 9. That makes this a 3, 4, 5, 6, 7. And I'm going to put that over here as well in this cell because they are equal. And let's stay with this cell and look in the row. There's a 4, so we can remove the 4 here, and it means we can remove the 4 here as well. Coming back, there is also a 5 and a 7, so we can remove the 5 and the 7. Also here, the 5 and the 7 can be removed. And finally, because of this 1, 3 pair, we can remove the 3 from this cell and the 3 from this cell, setting that value to 6. And that's a benefit to us, so we can move forward in the puzzle knowing that those two are 6s. So what's our next step? Let's look here in box 8 with this 5-cell 27 cage. It is impacted, well, this cell of that cage is impacted by these 8s in this 2-cell 11 cage, and these cells are impacted by the 8s here in box 8. So if we look at the possible combinations, we can remove any 8 from those combinations because all the cells have an 8 that prevents a combination containing 8. So there's an 8 there, an 8 there, 8, 8, 8, 8, and 8. That leaves 4. Okay, so that leaves 4, and all of them, if you look, they all have a 9. These 4 cells cannot have a 9 because they're in a box with a 9, this 8-9 pair. So the 9 must go here. Now, once we've set the 9, we can determine which of these 4 combinations are going to fit into the remaining cells of this 5-cell 27 cage by using this 6 here. These cannot be 6, and happy day, there are 3 of these combinations which contain a 6. So the remaining values in this cage are 2, 4, 5, 7, which force a 1, 3 pair into the last 2 cells of box 7. And let's keep going then in this cage with the 1, 3 pair and our 6 that we determined from our first crux. If we look at the possible combinations, there are only 2 that contain all 3 of those values, 1, 3, and 6. The first one does, the second one does not. The third one does, and the fourth one does not. So if we look up here to the 3 unknown cells in that cage, they cannot be a 9 because they are all in box 5 with this 9 that is also in box 5. And that eliminates all but one of the combinations. We know there is a 6 and a 1 and a 3, so the remaining numbers are 2, 5, and 8. So here we have 2, 5, and 8, 2, 5, 8, triple. And then moving up in the puzzle in that same column, this is extremely limited. The possible combinations are 4, 7, and 9. And here in row 1, there's already a 7 and a 9. So we know that this cell is a 4, and we can take the 4 out of the other 2 cells, leaving a 7, 9 pair. Now, this 19 cage with the 7, 9 pair, the only, the combination that has a 7, 9 is a 3, 7, 9. So this is a 3. Now, I have to tell you that I'm a bit sad, as in this solve path that I'm on right now that I'm recording for you, I'm not going to get to use this really unique, cool rule of 45 possibility. That is a 2 in and 2 out. So I will post an image and an explanation to my Killer Fun YouTube community page. So take a look in the description for the link for that, and hopefully you will find that interesting if you like unique shapes and logic. All right, moving on. So in box 2, let's fill in the remaining cells. The remaining possibilities are 5, 6, and 8. These 8s force the 8 into this cell and leave a 5, 6 pair in column 6 in box 2. Now this 5, 6 remove this 5 from down here. And I think that puts us on to crux number 2. So let's look in box 4. We have this large 6-cell 36 cage. And if we use the rule of 45, we can do the math. 45 minus 36. These 3 cells must add up to 9. Let's put that in our calculator. So we have a 1, 2, 6, 1, 3, 5, or a 2, 3, 4. Now, that combines with this 18 cage that overlaps in boxes 1 and 4. And we can use this overlap to help us limit the possible combinations. So to start with, let's look up in the combinations box and see what we can eliminate. The only place that contains an 8 in this box number 1, there's an 8 in these two cells, both of which are in the 18 cage. So we know there must be an 8 in the 18 cage. And we can remove any combination that does not contain an 8. All right, that leaves 4. So let's keep there in the combinations box. If we look and compare the two sets of numbers, we see that there are 8s here that are not down here, but that's okay because we know that the 18 cage contains an 8 in the cells that don't overlap. But there's also a 7 up here in this 1, 2, 7, 8 possible combination. The next way that we can eliminate possible combinations from the 18 cage is to look here at these two cells that are in box 1. We know that there must be an 8 in those two cells, and the only other two possibilities are a 2 and a 4. So the possible combinations are 2, 8 and 4, 8. So any of the combinations here in the combination box that don't have a 2, 8 or a 4, 8 can be eliminated. So this 1, 3, 6, 8 can be eliminated. Now, we can continue on and eliminate this 1, 2, 6 out of the calculator because there is no 6 here in the one cell of the pseudo 9 cage that sticks out of the 18 cage, and in the combinations for the 18 cage, there is nothing, neither of the combinations contain a 6. So we can remove the 1, 2, 6. And the final step in limiting the possible combinations of these, the combination box and the calculator, is looking up here at the combinations. They both contain a 5. So there's no 5. Well, they both contain a 5. So these, one of these must be a 5 because there's no 5 here. So we can eliminate the 2, 3, 4 as a possible combination. And we know that 1, 3, 5 is the combination that we'll use for this pseudo 9 cage. Now, this 1, 3 in the 4 cage of box 1 helps us eliminate the 1, 3 here. And if this is a 5, we can take the 5 out of this. So we end up with a 1, 3, 5 with a 1, 3 pair. And now we can do some cleanup to try and move forward in the puzzle after our second crux there. So let's look across here. We've got a 1, 3 pair. That eliminates the 1 here and forces the 1 into this cell. This 3, 8 and the 5 make this a 2. We can remove the 5 and the 8. And this 5, well, let's remove the 2 as well. And then this 5 here makes this an 8 and this a 5. All right, now we have 1s here and a 1 here. So we've got 2 rows covered by 1s, forcing the 1 in box 5 into this cell. We have 3s in this row and 3s in this row. We also have a 3 here in column 5, and that forces the 3 here. We've got 4s in this row, which forces the 4 here. Now, with this 4 here, we can eliminate the 4 from column 5 in this 27 cage. That forces the 4 into this cell. And with these 2's here and this 1 here, we can resolve this to a 1-2 pair. All right. So the remaining cells in box 5 are going to be a 6, 7. The 7 here and the 6's here force this to be a 6, 7 pair, eliminating the 6, 7 from row 4 of this 22 cage. And we can take the 9 out of the remaining 2 cells. All right, and let's look here in box 4, row 6, the remaining 3 cells in that column, or in that row. The possible combination there, 4, 7, 4, 6, 7. Sorry about that. 4, 6, 7. Now with this 7 and 6, this becomes a 4. We can take the 4 out of those. It makes a 6, 7 pair. This 6 resolves this. This is a 7, and this is a 6. All right. So let's move down into box 7 and look at this 4-cell 27 cage. It has a 6. So if we look at the possible combinations, this top one does not have a 6. It can be eliminated. There's a 4 in the row, and that eliminates the combination with a 4. So the remaining cells here are a 5, 7, 9. This 7, 5 here sets the 9 there. You can remove the 9's here, and this 7 sets this to be a 5, which means this is a 7. We can do some more cleanup here. This 4 forces this to be a 2, which makes this a 3. Takes the 2 out of these 2 cells. This 3 forces this to be a 1, and then this is a 4, which resolves this pair to be a 4, 8. And this, because of this 3, this is a 1 now. All right, this is also resolved. This is a 3, and this is a 1. Whoops. And let's see. What have we got here in box 7, the 13 cage? I believe we have a 2, 3, and an 8. Here we have a 3 and an 8, so this is the 2. We have a 3 here, so if this is a 3, 8 pair, this must be the 8, and this is the 3. Here in box 4, the remaining 3 cells are a 2. Let's see, 2, 8, 9. We've got a 9, 2 here, so this is an 8. Got an 8, 2, so this must be the 9, which leaves the 2. And we are making progress. Now this 8 resolves this 8, 9 pair in box 8. This 5, 7 turns this into a 2, and we can remove the 2 from those. That's a 5, 7 pair. I think we are all cleaned up for now. So let's move to box 9. why don't we look first at this 10 cage, this 4 and the 9, eliminate 2 of the possible combinations. Cannot be a 4-6, cannot be a 1-9, so it must be a 2-8-3-7, and there's some of those numbers in the rows, so it is even further limited. This cell can be a 3-8, and this cell can be a 2-7. So let's look at this 15 cage, 2-cell 15 cage, possible combinations 6-9 and 7-8. These 8s have something to say about that, both of them in the rows that correspond with this 15 cage. So 7-8 is not a possibility. And because of this 6 and because of this 9, we can resolve that to a 9-6. And looking at our 4-cell 16 cage with this one here and these 2 ones in these rows, the 1 in the 16 cage is here. So we know there's a 1. Now, we can go through these combinations and figure out which ones are left. Another way to do it, which is the way I think I'm going to go, is to look in the rows and see what's left in the rows. So there's a 5-7 here. This must be a 5-7 to complete a 5-7 pair. There's a 5-7 and a 2-7, so we have a triple there, a 2-5-7 triple. And there's a 3-8 here, so this is a 3-8. So those are the remaining possibilities for the cells in box 9. So I think this takes us, before I move on, I did want to point out that there is a really cool logic piece that because of this solve path, I didn't get a take. And again, I will take a screenshot and make an explanation of this unique kind of fun logic opportunity and post that to my Killer Fun YouTube community and put the link in the description. So if you're interested in finding out a little bit more about that, if you don't already spot it, go down in the description, click the link, and check it out. So moving on to what I believe is the third and final crux. We're going to look up here in box 3. But before we get started on that, I'm going to do a little Sudoku to set this up. If we look at this cell in row 2, column 7, this is a well filled out row. There are 5 known digits in this row. So there are only 4 possibilities, 2 of which can be removed because they don't overlap. This 5 and this 5 overlap, but the 9 and the 4 don't exist here. So the only possibilities for this cell are 7 and 8. And the crux is getting rid of one of those. Now, we can look in these columns and see that there is a 6-7 pair here and a 2-5-7 triple here. And I believe this is either an X-wing or somehow related to the logic of the X-wing. I don't know the details of that, but it makes sense to me when I look at it this way. If there was a 7 here, this could not be a 7. It would force the 7 here, and we would have 7s here and here. Now, the only other way we could fix this pair is to put a 7 here, which would remove the 7s from here and force the 7 here, so we would have a 7 here and here. Either way, the only 2 possibilities, there would be a 7 in both these columns and not allow a 7 to be in either of these columns. The 7 has to be here in box 3. because there's going to be a 7 here, or a 7 here, and here. What that means for us and row 2, column 7, is that it is not a 7. It is an 8, which helps us unwind a bunch of these pairs that are in boxes 6 and 9. So this 8 makes this a 3, which makes this an 8. If this is a 3, then this is a 7 here, which gets rid of the 7 there. We have a 5, so this is a 2. We look up here, this 8 forces that to be a 3, and that's an 8. This 7 forces this to be a 6, and that to be a 7. And this 2 makes that a 4, and that a 2. And I think I got those right. 6, let's see, 7, 6, 7, 2, 4, 2, 8, 8, 3. Okay. Now this 5 here also turns this into a 7 and this into a 5. And we can't do anything up here yet. So these columns are well filled out, and these columns are pretty well filled out, especially for the numbers 1 through 4. So if we take a look and just start doing some pure Sudoku, the ones here and the ones here force the 1 to be here, the 2 here and the 2 here, as well as the 2 here and the 2 here, force the 2 into this cell. These 3s in the columns and these 2 3s in the row force the 3 to be here. And these 2 4s in the columns and these 2 4s in the rows force the 4 to be here. Now there's not a lot left. We can start up here and look at this row 1. The only possibilities here are a 5, 6 to match this pair, but there's a 6 down here already in the column. So this is a 5, which makes this a 6, which makes this a 5. The only possibility here is a 7, the other part of the 7, 9 pair. This 7 forces this to be a 9, which makes this a 7 and this a 9. And the only possible remaining numbers are 6 and 7. We've got a 7 here and a 6 here, so this becomes a 6, 7. There you have it. Thank you for sticking around till the end. If you are still here, you must have appreciated the content, so I haven't asked for you. There are 3 easy things that you can do to support the Killer Fun channel. 1. Click that like button. Nothing but a click, yet YouTube promotes liked videos. 2. Subscribe by clicking the banner or the button. Again, just a click, but channels with more subscribers are given more features. And 3. Leave a positive or constructive comment. A bit harder, but far less time than you just spent watching. Comments are another sign to YouTube that this is quality content, and they will reward engagement with promoted views. Plus, I will know what I can improve or to stay the course. Please consider 1, 2, or all 3 of these actions to support Killer Fun. Thanks, and we'll see you next video.